Making sure you have an accurate scan is critical prior to beginning the interpretation of the OCT image. Before we dig in, let me remind you of some important terminology. This is a standard display when evaluating the optic nerve and retinal nerve fiber layer. The right eye is on your left. The computer segments the neural layers to create a measurement for both the neural retinal rim and for the retinal nerve fiber layer. For now, we will concentrate on the RNFL. The computer begins by placing a line at the inner border of the nerve fiber layer and the outer border of the nerve fiber layer. It then displays this data in different manners. This is the thickness map. Hot colors represent thick areas and cool colors, thin areas. The colorimetric band on the side serves as a reminder of the scale used. This adjacent map is called a deviation map. It has no colors on it when everything is healthy. Why? Because the colors represent deviation from statistical normals. We will cover this concept in later sessions, but for now, just remember that the scale for the deviation map is over here. All of that brings me to the concept of ensuring that you have an accurate scan. I will highlight 3 important points. The first one is signal strength. This is a score given to the overall intensity of the signal captured by the OCT device. The actual numbers may vary across devices, but in this training program, you can use a cutoff of greater than or equal to 7 to indicate a good quality scan. In this example, you will note a scan that would be considered to have poor signal strength. And that brings me to the second aspect. Segmentation errors. Segmentation errors are defined as a misplacement of the boundary lines auto-generated by the computer. These errors arise from poor signal strength, which can occur due to media opacities, among other causes. These errors lead to improper thickness maps and improper deviation maps. The final error is that of a movement artifact. This can be seen as a horizontal misalignment, easily noted by following the vessels on the deviation map. Despite excellent eye tracking software, sometimes the patient moves too much. The result is a horizontal misalignment that will affect your interpretation. Are you ready to try your hand on some real images? Join us at eyecarepd.com.